Alright, now moving on to example 2 of 4.3. Our instructions for example 2 are to form a polynomial function, f of x, with real coefficients having the given degrees and zeros. Okay, so we know our degree is 5, meaning in total we should have 5 zeros, complex and or real included. And then I see that some of the zeros I'm given are 1 with a multiplicity of 3. So that tells me that one of my zeros forms this part of my polynomial, x minus 1, right, to give me that 0 of 1. And I have this 3 times in my polynomial function. My next zero that they give me is 1 plus I. If I consider my zeros, my imaginary zeros, the same as I considered before my real zeros, I can follow the same form. So I have x minus my 0 to find this one. So x minus 1 gives me the piece of the polynomial function for 1, a 0 of 1. If I follow that same form here, I could say x minus my 0, 1 plus I, could give me that second piece of my polynomial function. Now, if we remember from example 1 and our earlier conjugate theorem, we know that if we have one complex 0, we should also have its conjugate. So my conjugate of 1 plus I is 1 minus I, so I should also have x minus 1 minus I as a part of my polynomial function. So there I have all of the pieces of my polynomial functions given by my zeros multiplied together. Our next step is to simply FOIL, distribute, get into that polynomial function form that we know of. Alright, so now we're in foiling mode. So let's start with the part that we already know how to FOIL. Straightforward, this x minus 1. So I know I have x minus 1 times x minus 1 times x minus 1 3 times, and then I can just copy down my other imaginary zeros that I have here. Okay, so all my pieces written out, and I can start my long process of FOILing. So x minus 1 times x minus 1 gives me x squared minus x gives me negative 2x. Negative 1 times negative 1 gives me positive 1. So first FOIL completed. Just copying all of this down. Now I need to distribute this trinomial and this binomial. Just continuing to simplify this out. So x times x squared gives me x cubed. X times negative 2x is negative 2x squared. X times 1 is plus x. Negative 1 times x squared is negative x squared. Negative 1 times negative 2x gives me positive 2x. Negative 1 times 1 gives me negative 1. Okay, and then I keep going, still doing all of this copying. Oh, up here I forgot my negative. Make sure that if you don't have that, you fix that. So x minus 1 minus 1. Lots of parentheses to include here. Okay, now I can combine like terms here. So I have x cubed. These two x squareds combine to give me negative 3x squared. These x's combine to give me plus 3x, and then minus 1. So I have taken care of multiplying out all of my unimaginary parts, those 3 polynomials, x minus 1 times x minus 1 times x minus 1. Now I need to go over and concentrate on my imaginaries. Okay. Now this part is really just FOILing. It's just a bit more complicated FOILing. So we're going to ignore this part for now and just concentrate on what we're doing with these two. So if I FOIL, I have my firsts, my x times my x, which is just x squared. My outer, x times negative 1 minus I, which gives me negative x times 1 minus I. So I'm just treating this like a number. Like it's negative 2, which is 1 minus I. So first, outer, inner. Again, treating this like a number, so it should be negative x times 1 plus I. And then my lasts. So I have negative times a negative makes a positive. And then I have 1 plus I times 1 minus I. So all of that, I have FOILed it. Sorry, can't see that. Okay. Now I need to start combining some like terms. Alright? So over here, I can distribute this negative x. So this becomes x squared minus x plus ix, if I just treat I like it's a number, because my coefficient. I can also distribute this one. So negative x minus ix when I multiply this one. And over here, I can FOIL this. So 1 times 1 gives me 1. 1 times negative I gives me negative I times 1 gives me I. And I times negative I is negative I squared. Okay. Still simplifying this. Okay. So I only have 1x squared, so I can just drop down my x squared. Negative x gives me negative 2x. Ix minus ix cancel out. It's just like having 2x minus 2x. And then I have negative I plus I. Those cancel. Then I'm left with plus 1 and minus I squared. Now, we need to think about what I squared is. So if I remember what my rule about what I is, I know that I is just square root of negative 1, right? Well, square root of negative 1 squared. These are inverses, my square and my square root, so they cancel, and I'm just left with negative 1. That negative 1 times this negative here leaves me with a positive 1 for negative I squared. Combine my like terms, and I have x squared minus 2x plus 2. And this takes care of multiplying out my complex pieces of my polynomial function. Now I just need to combine those with my real parts. Okay, so if we want to graph this, we can go to our calculator, turn it on first, clear out any functions we have in our y equals, and type in our factored out polynomial, x to the 5th minus 5x to the 4th plus 11x cubed minus 13x squared plus 8x minus 2. And then if I want to check that, I can always type in, well, for this one, because we have an imaginary, won't be okay to type in the second one to check it. But we can always graph it. Oh, right now my window is very off, so I'm going to need to change that. So if we want to change our window, we know we have zeros at 1, right? So we at least want to be able to see 1. For right now, I'm probably just going to go with the standard window, negative 10 to 10, and zoom fit. I can't exactly check my zeros yet. I'm going to have to zoom in on my polynomial function. So let's just actually zoom in over here, because I know I want a 0 at 1. let's zoom in here and see if we have that 0 at 1. So very tough to see with the Y window we have right now, so let's make this Y significantly smaller. 28,000 is not going to work. Let's go with -10 to 10 and see if this is working now. So a little bit better, still tough to see, so let's go even smaller. Let's just go -5 to 5. Okay. I can definitely see that I have that 0 at 1, but let's extend our X window to make sure that that's our only 0. Because we know since this is to the 5th, if we didn't do our work right, I might have extra zeros in there that I shouldn't have. So if we make this from -10 to 10, we wait for our function to graph, I can see that the only time this crosses my x-axis is at 1. So at the very least, I can check that those real zeros are zeros on my function, and there are no more zeros added because maybe I didn't do my work right and multiplied wrong. Now I have more zeros than I'm supposed to. So a good way to check is always to graph it and see if it matches up with the things you were given in the original question. Okay. Alright, so that's just one way to check. Okay, so we just did example 2a, and I showed you one method of how to do this example. There is another method to doing this example. It might be simpler if you think it is simpler. It might not be. But we need to make sure that we understand the concept behind it, because it's not just a trick. It's another way to conceptualize this idea. So when we solve for zeros, we end up getting something like this, right? So we would say x minus 1 equals 0. And when we solve for our 0, the reason we say x equals 1 is because we added that 1, right? So what if we started at this step, this x equals 1, and then just backtracked until we had our polynomial? So if we think about it, before this is essentially what we did. We were given the 0, 1, we backtracked to put it back in the form of the polynomial. So now let's consider our imaginary, our complex. So we know that we have x equals 1 plus I, but that's really, if I'm backtracking, 1 plus or minus I, right? Because when I solve my polynomial, I'm actually given the 1 plus or minus I, and then I separate them into the two conjugates. So I'm really given x equals 1 plus or minus I. Now if we thought about these as numbers, our goal, when we went from here to here, was to have this equal to 0, right? It's one of our zeros, so it should equal 0 in our polynomial. So we take this step. So here now, we would want this right side to equal 0, so that if I plugged it into my polynomial, it would be a 0. It would equal 0 when I multiply. In order to get this side equal to 0, I need to move some things around, right? So to get rid of the 1, it's easy. I can just subtract 1, right? So I can have x minus 1 equals plus or minus I. Now I could also subtract and add my plus or minus I, but I know that I don't want to have to deal with an I, an imaginary part, later in my function. So if we bear this in mind as we go, we realize that here is when we want to get rid of this I. So if we consider what I is, earlier we reminded ourselves that I is actually just the square root of -1. If we consider what the square root of -1 is, in order to get rid of what makes it imaginary, this square root, I need to get rid of the square root, right? We get rid of square roots by squaring. It's the inverse, right? So if I think about it, if I square this side, I have x minus 1 squared over here. On this side, this is really plus or minus square root of -1 squared. Anything squared is always positive, so I can just pull these out to make that plus or minus positive. I know if I square the positive, it'll stay positive. If I square the negative, it will become positive. So those are both going to condense to that positive. And then when I square that negative 1, my square and my square root cancel. I'm just left with negative 1. Okay. So I've gotten rid of my imaginary piece. I'm left with x minus 1 all squared on the left side. And I'm left with just negative 1 on the right side. Now, remember, as we're backtracking, our goal is to have the right side equal 0, because whenever we have a factor, we know that in our function, that should be 0, right? So we're trying to make the right side 0. Now that I just have a negative 1 on the right side, I can get rid of it by adding it to my other side. So if I add 1 to this side, then I should have that equal to 0. Now it kind of resembles what I have here, right? I have this expression of x equals 0, just like I should have for one of my zeros, one of my factors. However, if I want to multiply this out into a polynomial, I need to get rid of this squared piece. So we need to FOIL this out. X minus 1 times x minus 1. So x minus 1 times x minus 1 gives me x squared minus x, which is minus 2x, plus 1 when I multiply. And then I have my other plus 1 equals 0. Combine like terms, and I have x minus 2x plus 2 equals 0. And this would be what I would put into my polynomial function to represent those two imaginary polynomials, those factors. And if I look back at the work I did before in that problem that we worked on earlier, I can see that after I finished doing all of this multiplying and foiling and rearranging of my conjugates, my imaginary pieces, I got x squared minus 2x plus 2. I received the same thing here, x squared minus 2x plus 2. You can use either method to achieve this result. However, you need to understand the theory behind both of them and know how to implement them into the problem. So understand why we are doing these things. Make sure you know what our purpose was and why we were setting this equal to 0, why we were allowed to solve this the way we were.